The third parameter that all the models agree on is related to the rise in sea level. No model shows that as the climate warms, we will have a constant sea level. All of them predict that the sea level is going to rise, although some models will predict a little bit less, others a little bit more. And this is obviously due to two different factors. One is the thermal expansion of seawater. When the oceans themselves get warmer, the warm water will take up a larger volume, and so the sea level will rise. But today, most of the sea level rise, and in the future, will be due to the melting of the glaciers and the ice caps that we spoke about in the class on the cryosphere, which is going to result in a direct increase in sea level. The amount of the sea level will obviously depend on the amount of the warming and the amount of the melting. And here we can see, both looking back in time, the measurements of sea level based on tide gauges in different harbors around the world. And then we have the satellite data in the more recent period, and the predictions again of what may happen into the future. The lower and the higher estimates where it's possible that we may get to 1 meter sea level rise by 2100 in the business as usual, the highest scenario of global warming. Now, to check that how the models do and the predictions of the models, it's actually nice to go back in time and see what did the models predict would be for sea level rise, say, in the first IPCC report in 1990. And that's shown here by this gray region, which the scenarios out to 2010, for 10 years later, what would be the rise in sea level. And the actual observations are shown by this blue line. And what we see is actually this was at the upper edge of the predictions from the models, and where some people say that the scientists are exaggerating with their models and that things can't be as bad as they say it can be. Well, here's an example where the scientists were underestimating what was going to happen with sea level rise, and the rise in sea level is actually at the upper boundary of all the model simulations. And so this may also occur with other parameters going into the future. What's the impact of a few meters sea level rise in different parts of the world? Well, let's take a look at Egypt, the Nile Delta. We can see the coastline more or less today. The coastline with a 0.5 meter sea level rise in the middle, and at the bottom, what would be underwater if we had a 1.5 meter rise in sea level. Alexandria, Port Said, many of the big towns on the coast will be underwater. Today, we have about 8 million people living within 1.5 meters of sea level in Egypt along the Nile Delta. These people are going to have to move. The cities will have to move. They have to find new jobs. And this is today 8 million. This population in Egypt is going to double in the next 30 years. So by 2050, 2060, there's likely to be 16 or more million people living in that area. The rise in sea level is not going to occur from today to tomorrow, but we have to plan that in the next decades, if we continue in the same direction, we're going to have to move and relocate huge amounts of populations in coastlines which are going to be flooded. And especially in developing and poorer countries, this could have a huge impact on climate refugees, which are going to have to move both internally in countries, but maybe also internationally to other countries looking for food, water, and jobs. If we look at Bangladesh, another problem, if we look at a rise of 1.5 meters in sea level in Bangladesh, on the left we can see the regions where we have very heavy populated regions in the darker green, and on the right we can see in blue the areas which will be underwater if we have a 1.5 meter rise in sea level. In that region, there are 18 million people that live there today, and this is also 22,000 square kilometers of fertile agricultural land which will be underwater. So these increases of just 1-2 meters in sea level are going to have dramatic effects on many countries around the world, and especially in the developing world where both the huge populations living in these regions, and it's a huge source for agricultural crops and the economy of these countries. We can go even further and look into the future. What would happen to different coastlines if we had a 5 meter sea level rise, which likely won't happen in the next few hundred years, but it could happen. And you can see here in different parts of Europe, Florida, parts of Florida underwater, and areas in Borneo, in South America, be significant impacts on cities around the world if we have a few meters sea level rise due to climate change. And again, from the IPCC report, we can see the different scenarios out into the future. But if we just focus on the bottom, the sea level rise, normally these scenarios are given just out to 2100, where we say we may have a 1 meter sea level rise. But obviously things don't stop at 2100. And on the right, we can see the possibilities if we continue in these same scenarios out another 200 years to 2300. This is the times when our grandchildren's grandchildren will be living here on planet Earth. We can see that the business as usual scenario, the red plot, gives us maybe 4-5 meters sea level rise in just a few hundred years. And even the most optimistic scenario gives us maybe 1.5 meter rise in sea level. So we need to think also beyond 2100. We have to look out hundreds of years into the future. And again, with sea level, it'll be very difficult to turn the clock back once we have a sea level rise of a few meters in the future. Again, to reduce sea level takes tens of thousands of years. It'll be much too difficult to do, and therefore we're going to have to live with any of these scenarios in the future if they occur. When it comes to temperature and rainfall, we may be able to reverse those by reducing greenhouse gases, but once the sea levels rise, we're going to have to live with that.